Hello and welcome. I'm Edwin, a developer on the Cloud Solutions team here at Terraform. In this video demo, we'll be going over the GCP Quickstart deployment. This video will mainly be a basic walkthrough of using the GCP Quickstart tutorial, so that way we can get you a copy of Terraform's cloud access software running in your cloud environment as quickly as possible. Please note that these cloud deployment scripts were meant to be used with the CLI and Terraform, so a separate and more detailed tutorial of our single connector deployment is available, and it is highly recommended. So let's get started. Our cloud deployment scripts can be found on GitHub. The URL is github.com/teradici/cloud_deployment_scripts. Here you'll find a short introduction to our cloud deployment scripts, as well as documentation for both AWS and GCP. We'll go ahead and click into the GCP link. As this demo will be doing the quick start, we can click on GCP Quickstart Tutorial. This will bring us to the section, and here you will find a blue button that says Open in Google Cloud Shell, as that's what we'll be using to make our deployment. We'll go ahead and click on that. And we'll get a message here to confirm that we want to clone the repo. So we'll click Confirm. And our Cloud Shell editor and the Cloud Shell console will initialize. Great, looks like it's done initializing, and it's also cloned into our virtual machine. So here we'll open up a Quick Start tutorial tab on the right side, and we can go through this together. And on the left side here, it opens up the configuration file. So here's the introduction. The goal of this tutorial is to create the single connector deployment in as few steps as possible by using Python and Terraform scripts. So we'll do this by using a few parameters in a configuration file before we show you how to use a Python script in the Cloud Shell, which will create this Cloud Access Connector deployment. The Python script is a wrapper script that sets up the environment required for running Terraform scripts, and this creates the actual GCP infrastructure, such as the networking and the compute resources. Once we're ready to start, we can click on the Start button in the bottom right corner. The first step will be to enter the parameters required in this configuration file. The configuration file should already be open in your cloud editor. If it's not, you can click here to open it up. The first parameter we'll need to fill out is the PC/IP registration code. If you don't have one, you can visit the following link to get in touch with our sales team. Since I already have a registration code, I'll go ahead and paste mine in. Our next parameter is the Cloud Access Manager API token. We can log into CAM by visiting the URL cam.teradici.com. I have a tab open here already, and I've already been logged in. In the top right corner, we'll see our email address. Just below it, we'll see the Get API token. So we'll click on that, and you should see a token that expires in about 2 hours, and then we can click on the copy icon here to copy it. And we'll head back into our Cloud Shell, and we'll replace this value here with our API token. It is quite a long string, so we'll just have to scroll back up to the left side here. For the next 4 parameters, scent, gsent, swin, and gwin, these are the parameters for the number of workstations of that type that we'll be creating in this deployment. If we look on the right side in the tutorial tab, we'll find the parameter as well as a short description for what it is. When filling out the number of workstations to create, please be mindful of your GCP project quota. You want to ensure that there's sufficient CPU, SSD, and GPU quota in your project for the chosen number of workstations, and this is on top of the domain controller and the Cloud Access Connector, which will also be created. For this demonstration, we will be deploying 1 standard CentOS and 1 graphics Windows. In the next step, we'll save this file using Ctrl+S. For the next step, we'll need to ensure that we have the proper project selected. If you don't have a project created already, we can head over to the GCP console, and in the top blue menu bar here, we can click the drop-down menu and click on New Project. We'll need to give it a unique project name and fill in the required fields and hit Create. I already have a project, so I will not be creating one. However, we do highly recommend creating new projects to reduce the chance of name collisions as well as resource collisions. So here, once your project's been created, you can look for the project ID, and that's what you will be using for this command. So we'll go ahead and copy our project ID here, and we'll go back to our Cloud Shell, and we'll enter the command here, gcloud config set project, and we'll paste in our project ID. So you should see a message that says updated property, and then also a yellow text here showing that you have the project selected. For the last step here, we'll be running two commands. One will be changing directory to our Python script, and then the other one will be executing the Python script. In our tutorial tab, we can also click on Next to make sure we're following along. We've already completed the first step here, which is selecting the project. Next, we'll be running the script. First, we'll need to change directory as we are in the Cloud Deployment Scripts directory. So we'll use the command cd quickstart. Once we're inside the quickstart directory, we can run the execute command here. We can copy this command here and just paste it into our Cloud Shell. Before the deployment, the Python script checks for all prerequisites such as Terraform version 0.12 or higher, as well as the required Google Python packages. Here we are prompted with a message to install the required Google packages. We'll go ahead and press Y for yes and press enter. Once that's completed, we'll be prompted to enter a password for the Active Directory Administrator account. We'll go ahead and enter a password and confirm the same password. The script will now continue with the deployment. It will set up things such as the Cloud Access Manager deployment, as well as the CAM API key and everything else it needs to basically create the deployment. Once the prerequisites are finished, Terraform will initialize, and also it will begin the deployment process. The Terraform deployment will take roughly about 20 to 30 minutes. Once that's finished, the Python script will add the existing workstations that we've just provisioned to CAM. We'll come back once the Terraform deployment is complete. Once the Terraform portion of it is finished deploying, we can see that 31 resources have been added, and we can also see a green output message in the console. This will contain information such as the IP addresses of the VMs we've just created. If we head over to the GCP console, we can find the VM instances list under Compute Engine and VM instances, and you can see the VMs we've just created. Here's a graphics Windows, a standard CentOS, a connector, as well as a domain controller VM. If we scroll down a little bit, we'll see that the Terraform deployment is complete. We'll also see that the script will try to add the workstations we've just provisioned to Cloud Access Manager. If we head back over to CAM, under the top menu here, we can select the deployment. Quickstart creates a new deployment called Quickstart Deployment with a timestamp. So we'll go ahead and click into this deployment. Once we're inside, we can click on Connectors, and we should see the single connector that was created by Terraform. Here you'll see a health check. If the deployment just finished, this may appear unhealthy, and this is because the state is not immediately synced up to CAM. If we wait a little longer, this should turn healthy. We'll also see that the external and the internal IP of the connector should match the console output in the Cloud Shell here. Once that's been added, we'll also see a message here that we're waiting for the administrator user to be synced up. So once that's synced up, it will add the user as a user entitlement to these workstations. Two next step messages are also printed on the console. The first one is connecting to a workstation we've just provisioned, and the second is adding additional workstations using CAM. Finally, a cleanup section is also printed on the screen with steps on cleaning up the Terraform deployment. If we click on Next for the tutorial, we'll also see the next steps and can follow along. To connect to a workstation, we'll need to first download and install the PC-over-IP client. If we open up a new browser tab and head over to terradici.com, under Products and PC-over-IP clients, we'll find the different clients that are available on different platforms. There's also an administrator guide for each of these clients if you require further instructions and assistance. I already have mine installed and set up, so I'll just open it up. In order to connect to our workstations, we'll need the public IP of the Cloud Access connector we've just deployed. We can get this public IP from either the Terraform output message in our Cloud Console or using CAM. Here in CAM, we can click on Connectors page and we'll see our single connector as well as the external IP for that connector. We'll go ahead and copy this value, and then we'll head back over to our PC over IP client and we'll paste in the IP address and click on Next. A pop-up message may appear saying that it is insecure, and this is because the Quickstart does not use the SSL certificate option. So for this demo, we'll just connect insecurely. Here we'll enter the username and the password. By default, the Quickstart uses the user administrator, and the password will be the password that were set out by us at the beginning of the Python script. So we'll go ahead and enter that password in. And then we'll click on Next. Once we're logged in, we should see the machines that are now assigned to the default user administrator, and we should see both the standard CentOS and the graphics windows. One thing to note when connecting to these workstations, immediately after the Python script is complete, some of the workstations, and especially the graphics ones, may still be setting up. So sometimes here you may see a message that says remote desktop is restarting. If this happens, we'll just need to wait a few minutes or reconnect if it times out. We are now ready to connect to our Windows graphics workstation. So we'll click on GWin and click on Connect. The connection should only take a few seconds to set up. And once it's loaded, we should be brought into the Windows desktop environment. For better viewing experience, we can click on View and Show Full Screen. What this will do is actually resize our desktop. And this way, it'll seem like we're in a native Windows environment. One thing to note for all these workstations is that they are in a private subnet, so they're not exposed to the public internet. However, they still have internet access since a NAT gateway had been created and configured for the workstations to use. If we open up a browser, such as Internet Explorer, we can visit a web page such as terradici.com, and we should see that we do in fact have internet access. So you may get a couple security warnings here, and that's just because of Internet Explorer by default. And here we do see we can load a web page. Feel free to pause the video if you like to explore the Windows workstation further. The next section will deal with the proper cleanup and deletion of our deployment. So just one last item before we move on to the cleanup section is the addition of more workstations. So if you like to provision more workstations, we can do so by using CAM. So we can first log in to cam.terradici.com, and so I can open up the dashboard here. Under the deployment that we've created, which is the Quickstart deployment, we can head into the Workstations tab, and here we can click on the plus icon, and we can create a new remote workstation this way. We can create a new remote workstation by selecting the proper template. We'll need to give it a machine name, and we'll also need to select the region that we've made our deployment in. So we'll go ahead and select something like CentOS Standard Agent, and we'll call this Ascent 01, and we'll need to select the region that we've made our deployment in, which is US West 2 by default for the Quickstart and 2B. And the network will be the network that we've created, which is VPC CAS. And the subnetwork will be subnet WS. We'll select a machine type. We can choose something like a 4GB for virtual CPU, and just the standard persistent disk will do. Give it a size of 64, and we'll enter the Active Directory information. Here, if we refer back to the Cloud Shell tutorial, we can see basically all the parameters that we'll need to add a remote workstation. So here we've specified the region West 2, 2B, VPC CAS, subnet WS. The domain name will be example.com. The service account we'll use is cam_admin. And then the service account password is the password that we've set at the beginning. So once we have this filled out, we can click on create. So let's go ahead and finish that off. So we'll use example.com. And then we can click on create to finish this process. And once it's created, we'll see that the power status is that it's creating. This process may take up to 10 minutes for the new VM to provision. And so once it's complete, this power status should appear running just like the other two. We can now move on to the final section, which is cleaning up our Terraform Quickstart deployment. The first thing we'll need to do is to delete all workstations that were created by Cloud Access Manager's web interface, such as the standard CentOS we've just provisioned. The resources that are not created by the Terraform scripts from our Quickstart script initially, these must be removed manually before Terraform can actually properly destroy all the resources it created. If we head back over into CAM, we can select the VM we've just provisioned, which is the standard CentOS 01. And then under Actions, we can click on Delete. We'll also be prompted to delete this workstation from GCP, and we'll want to make sure we check Yes here, as this will remove the actual VM from GCP's console. So we can click on Confirm, and we'll see that the entry is deleted, and we should also see that in the GCP console that the VM has been removed. We're now ready to run the final command, which is Terraform destroy. This command will clean up all the resources created during the provisioning process by Terraform. We'll first need to change directory into the GCP single directory, which is where our deployment was made. We'll change directory by using the command cd:/deployments/gcp/single-connector. What this will do is change directory into our Terraform deployment, which is under GCP's single connector. Once we're inside the directory, we can use the Terraform destroy command. And we'll be prompted a message to confirm. And here it is. We'll see that there are 31 resources that we'll be destroying, and we'll enter the value yes. The destroy process may take up to about 5 minutes, so we'll come back once it's finished. With Terraform destroy complete, we can now head back over into GCP console to make sure all VM instances have been properly destroyed. Under Compute Engine and VM instances, we should no longer see a list of VM instances here. The last and final step of the cleanup process is to go into Cloud Access Manager, and we'll have to manually delete the deployment that the Quickstart script had created. So back in CAM, we'll select the Quickstart deployment and we'll click on Delete Deployment. Now we're all finished. With the cleanup process complete, this concludes our GCP Quickstart video. We have another video that goes into more details, and it is much more in depth for the GCP single connector. So please check that out. Thank you for watching.